Code is hard to reason if it's of poor quality. Also, errors often creep into the code. The code becomes more error prone if it's of poor quality, and you want to really write better quality for that reason. But you may wonder at some point, right? You may ask the question: is it possible at all to write really good quality JavaScript code? And part of the reason is how did a lot of us learn JavaScript? If it's a language you are learning other than JavaScript, you probably took the time to maybe read a book. You probably took the time to go through some tutorials. You probably took the time to maybe in some cases take a course. But when it comes to JavaScript, we don't really want to take the time to learn it formally. A lot of people who learn JavaScript learn by reading JavaScript off of web pages. And in fact, I said used to because nowadays we don't even bother with that. We just copy and paste the JavaScript on the web, and the poor code just gets carried over to projects, and it becomes a disaster to maintain it. So you can write good quality code. You can write good quality JavaScript as well, and there are certain things we can do that are common to any code you write, and those apply to JavaScript as well. Then there are things that are more specific to JavaScript we can talk about. So let's do that. Let's first talk about things that are general enough, and then let's talk about things that are specific to JavaScript and how we can write better quality JavaScript over time. And then as a third part in this presentation, we will talk about tools we can use to make our lives a little bit better. I'm not a fan of using tools alone, but a tools in combination with being aware of what we do, being intentional, can really make the code a lot better. So the first thing is you can think about good software design principles. Those principles apply to JavaScript as much as they apply to any other language, whether you're programming in Java or C Sharp or whatever. Similarly, you can do those things with JavaScript as well. So in that regard, let's talk about one principle or two principles, and that is you could talk about high cohesion and low coupling. So what is high cohesion? High cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well. That's basically what cohesive code really is. So what is the purpose of making code cohesive? A cohesive code changes less frequently. So if a code is cohesive, like things are together, then the reason for it to change is a single reason. It doesn't change for multiple reasons. That's one of the benefits you're going to get out of that. So you want to make the code cohesive. So cohesive code changes less frequently, and as a result, it becomes less expensive to maintain. What about low coupling? Low coupling is where you want a piece of code to depend on fewer things. If a code depends on fewer things, then the frequency of change again is less. If a code depends on many things, the code becomes more fragile and it becomes more expensive to maintain it. So you want to really reduce coupling. You cannot reduce coupling to zero oftentimes. That's really, really hard. In some special cases, you may try to reduce it to zero, but practically speaking, you really want to, reduce coupling as much as you can. One approach you can take to reduce coupling is to use a facade pattern. So you don't want to be doing manual efforts over and over and over. You want to really remove a duplication of effort. When it comes to duplication of effort, you want to really think about places where you might be repeatedly doing stuff that you can probably eliminate. Let me just give you an example of this, in terms of how and where you can think about these things. So imagine, this is file one, and imagine over here this is, let's say, file two, right? So I don't want to be switching between files right now. So just imagine I have two files in here, if you will. So if I have multiple files like that in my application,
you want to think about the consequences of some code that we are going to write. So, for example, let's say you are interested in creating a function. We'll say, for example, Sam is equal to a name is going to be Sam, and we will say age is going to be 2, like so. So we have this, Sam and age, and I'm going to say a constant older Sam is equal to increment, let's say increment age, and I'm going to pass Sam over here. Now we want to follow immutability. We don't want to be mutating objects. So what you could do is you could write a function called increment age, which takes a person, if you will. But what am I going to do within this function? You might be tempted to do something like this, right? You could say return, and you could say name is going to be person.name, and then you could say age is going to be person.age plus 1, right? So you are creating an object with an incremented age, and then when you're done with it, you could say, hey, here was the Sam, and here is the older Sam that we have right now. So you can see the age went from 2 to 3. When we write code like this, it's very easy for us to not think of a certain consequences, and we may be very genuinely writing code. We may not think about what did we do, what can we improve, until later on we realize that we got to keep chasing this code over and over. Now, when you look at this code, you will, so 2 design principles are violated in this code. And that is kind of the funny part about a code like this. So anyone wants to take a wild guess, what are the 2 design principles violated in this? And you kind of look at this and like, gosh, you read 1 line of code and you violated 2 principles already, right? So what do you think are the 2 principles we violated in this? Anyone wants to take a shot? What? Go ahead. We did not, right? We did not mutate the original object, right? We returned a copy. So what are the 2 principles? Any try? Bingo, love it, awesome. So the first thing we violated is the open-closed principle. And it's a little hard to see that, right? And I'm glad he saw through it. We'll talk about that in a minute. I'll come back and talk more about this in a minute. What's the next principle? I know why you're not saying it, because you don't want to repeat it, right? Good. So it's a dry principle. How is it a dry principle? Let's talk about that. That's the easier one because you can see it first of all. How is it a violation of dry? Because for every member, you are making a copy of it, right? You said name is person.name. That's duplicated effort, isn't it? So that's why it's a dry violation. But he said, you violated the open-closed principle. Like, how is that possible? Well, the reason is, remember these are in different files, right? So a few weeks go by and your requirements change. And what does your requirement say now? Maybe Sam has a Twitter account. And this is, Sam, example. And now what's going to happen? It's like mom and dad found out that Sam has been tweeting at the age of 2, and they withdraw the Twitter account, and now you don't have the Twitter account. So what should you do? You got to come back now to this code, and you got to modify this code again and say, Twitter, and you got to change the code, right? That's a violation of open-closed principle because the code is never closed from modification to the object. So when you start thinking about these things, they say the first step in solving a problem is to understand there is a problem. If we don't even know there is a violation of principle here, how in the world could we solve it? So the minute you say, hey, there's a violation of a bunch of principles, how can we solve it? We can now ask the question, how can we go about solving these particular problems? So let's go back and say here is a Sam, and let's assume that Sam doesn't have any Twitter account right now. This is all we have right here at this point, as you can see. But what I'm going to do is, I'm not going to violate those principles now. So instead, we simply say, go ahead and copy the person object and then the age object. So notice now what just happened. You're saying gobble up the whole person and then change the age alone. And then, of course, when you run the code, you can see that worked. But then you say, as time goes on, we're going to add a Twitter, but you don't have to change any code. Because the code says, no worries, if you have new properties, we'll copy them over. So the code now complies to open-close principle, and you're not duplicating the effort for every single field, right? So those are the things you want to keep thinking about when it comes to writing code. This is what I enjoy as well. When I write code, I just don't write code and walk away. You write the code and you pause and say, how does that feel? Is that code good enough? Can it be better? What are the deficiencies in it? And we tend to analyze these, and then we tend to, you may not know the answer for these a lot of times, but that's okay. It's unbelievable the world we live in. When I was a young student, we didn't have Google, right? My children always find this fascinating. They look at me and say, Dad, what does it mean there was no Google when you were a kid? And I would say, yeah, we didn't have Google. There's no internet back in time. And then they would say, then how did you keep yourself safe from the dinosaurs, Dad? And they think that the world did not exist, between the time when there were dinosaurs and there was Google, right? And it's really, really strange for them to know. But there was a time when there was no things like you can look up, you cannot look for stuff. So we had to go to libraries and look for books and find answers in them. Well, in today's world, it's completely inverted. The world is filled with answers. The only thing you need to know is the right question to ask, right? If you ask the right question, you're going to find the answer. But the challenge is really asking the right question. That's exactly what this is, right? You're asking the question, is the code of good quality? The minute you ask that question, you're able to get the answers through. That's the very first step in there. So we talked about some principles we can really use, but moving forward, there are a few things you want to keep in mind when it comes to writing JavaScript. So we went from common things that you can think about in multiple languages, but more specifically to JavaScript, what are the things you want to think about? Now, so let's take a look at an example of this just to get a feel for it. So let's say a constant a equal to 1, and we have a constant of b and let's say a c. So in here I say I have a which is a string, I have a c which is a string as well right there. So I'm going to provide that particular string, and then I'm going to say in here output, we'll say output a is equal to b. So notice it says a is equal to b, it says true. Then I say b is equal to, let's say, c. So it tells me true. Now, this is where I say, please do not show this to children, right? Especially if you have children who are inclined in logic and math, never show this to them. Because the minute they see it, they lose faith, complete faith in what we do, right? Because what do we know from the world of logic and math? If A is equal to B and B equal to C, what can you infer? That A is equal to C, isn't it? So now you run this code and JavaScript says no, right? I mean, how do you reason with this code? And A is equal to B and B equal to C, but A is not equal to C. Now you're sitting and scratching your head, what in the world is happening here? The first problem is using the word logic and JavaScript in the same sentence, right? So in this case, when you perform A is equal to B, JavaScript says, oh, A is a string, B is a number, the types are different, so I'm going to perform a conversion and comparison. So the first comparison is a convert and compare. The second one, B equal to C, is also a convert and compare because the types are different. On the other hand, A equal to C, that is the same type, and of course, string of 1 is not equal to string of 1.0, and so it gave a false. So what's the moral of the story? The moral of the story is do not use double equals to compare unless you have a very special situation. So instead use a triple equals. And so basically here you're saying, I want to compare this with a triple equals in all of these, and notice it's a false consistently. And the reason is a triple equals is a strict comparison rather than being a convert and compare. So the moral of the story is if you're writing JavaScript, you should not use double equals, you should use triple equals. Now, having said that, how many of us program only in JavaScript and nothing else? Yeah, but 3 or 4 people, right? How many of us program in JavaScript and fill in the language, right? Java, C#, that's most of us. So what does that mean? Excuse me, what that means is you're sitting and writing Java code and you're going to use a double equals. And then you start writing JavaScript, is your mind capable of immediately flipping over and writing a triple equals, right? If you do, you need to go into counseling, right? That's some kind of a mutation that makes you do that. Most of us cannot do that. You put a double equals here, you put a double equals there. Then you program in JavaScript for about 2 days, you put a 3 equals, and then you come to Java, you put 3 equals. And Java is like, dude, what are you doing, right? So this is like constantly going back and forth. And there's no point in blaming ourselves. So what you want to do is to rely on tools to help you with this. Maybe you're using an IDE, and the minute you start putting double equals, it converts to triple equals. That'll be really nice if there is one. Or you can use tools that will verify the code and say, hey, I saw you use double equals. That's okay, I won't tell anybody, but I'll give you 10 seconds to change it. And starts counting down 9, 8, 7, and you immediately change it, and you're good, right? So essentially, rely upon tools to help you with that. That can be really, really helpful. So that's one thing to consider is to be able to do it. The second thing is use variables. Using variables before defining them is a terrible idea. You want to define variables and then you want to use them. So why is that important? So for example, let's take one example here. Suppose I said, let's say a function, we'll call it as, let's say a function, oops, let's see again, there we go. Now it wants to move. Let's try this again. So here's a function, I'll call it inner, and the inner function does the following, right? It says for I equal to 0, I less than 5, I plus plus, and what does it do? It simply says, output, let's say in this case, high. We'll keep it a little 3, right? So we'll do that. Then I have a function outer, and what does the outer do? The outer simply says for I equal to 0, I less than 5, I plus plus, and I'm going to then say call inner, right? So basically, very simple code, and I'm going to call the outer right there. Now, I won't run the code yet, but if I run the code, what is the output I would like to see, right? I would like to see a high being printed 5 times 3, 15 times. Is that reasonable, right? So we are looping through 5 times, calling inner, and the inner is printing high 3 times. 5 times 3 is 15. Any thought on what the output is going to be? It would be nice if it is 15 times high, right? But what could be the output? 5 times? 8 times? 3 times? So let's go back here. Let's try this and run the code and see what it does. What did it do? It's still running, isn't it? Is it done? We can wait, right? We have time. So it went into an infinite loop, didn't it? Honestly, if you asked me that question, I would have said the same answers you gave, right? Because it's misbehaving, but why did it misbehave like that? So as it turns out, excuse me, what happened in this case? You call the outer. When you came into the outer, what is that variable I? Did you define the variable I? So the JavaScript interpreter says, oh my goodness, did you notice? Venkat used I without defining it. What can I do to hurt him the most? And it figures that turning a variable into a global variable is the nice way to give a punch in the stomach, right? And you're like, ouch! And you're like, yeah, take that, Venkat, right? And now you're like, next time you're writing code, you remember that pain, right? This is the best way. Forget compilers, right? They screw this so much, you will never forget this. You won't write code like this, right? That's a nice lesson. No, just kidding. Only a little bit. So the point really is, on the other hand, if I say let, and if I say let right there, what's going to happen? So now if I go back and run the code, you can see it ran that many times and it finished. So the moral of the story is, do not use variables without defining them. Well, okay, that's easy to say, but wouldn't it be nice if we have some friends to help us with this? And this is where we can say, option strict, and you can say use a strict right there. And when you run the code, you got an error, right? It says, look, you're using a variable, but you haven't taken the time to define it. Sorry, you cannot use it, right? So that's basically the error that you're getting right there, is that it doesn't allow you to use variables without defining it. So you don't want to really go into a global scope, so you can use a use strict. If you're using JavaScript modules, the use strict is automatically given to you. You don't have to say it. That's one of the nice things about JavaScript modules, is that's a lot more safer. Now, having said that, you definitely want to quit using var. So let's think about var for a second. Let's say we have a function foo, and within the function, I'm going to say var local is local1 equal to 4, and I want to print out local1, right? Let's say location 1. So I want to call foo, and you can see that it prints a value of 4. So far, so good, right? Then I say over here, a little curly brace, var location 2 equal to 5, I want to print out location 2, right? Not a problem. But now I come out of the curly and I say location 2 like so. What's going to happen? Well, JavaScript looks at this code and it says, did you notice that? Nice curly, and throws it away and keeps walking. So it doesn't have a block scope, unfortunately. And as a result, in this particular case, you can see that it brings up location 2 at the very end as well. Now, obviously, that's not a good practice. So what can be done? You could say, gosh, if that's really broken, the language should fix it. But keep in mind, you have a certain amount of luxury in other languages. If you're writing code in C#, Java, Python, Ruby, whatever language, right? You control the version of the language you are using. So if you decide to change the version of Java, you can say on my machine, on my build system, I'm going to use this version of Java. You don't have the luxury for JavaScript. Why? Because you take a JavaScript and you send it to a random browser, and the browser could be a very old browser. Or a browser says, I'm going to only support a certain version of JavaScript. And then all the code that's coming to the browser is an old version. All of them are broken. Nobody's going to use that browser after that, right? So you have to be backward compatible. So what they said was, okay, That's really terrible, but we'll quietly pretend like that never happened. So don't use var anymore, use let. So if you use let, block scope exists for let. It doesn't exist for var for backward compatibility. So if you go back to this code, notice it did not give us an error. But if I change it to a let, notice that it gives us an error because the location 2 is not defined, it's a block scope. So the moral of the story is a few things you want to consider. The first thing is use const as much as possible. Use let where const is not possible, and forget var, right? So don't use var. Var is terrible. Don't use it. Use const as much as you can. What's the benefit of a const? Const gives you immutability of the reference. Objects are not immutable still, but references are, so you can protect yourselves from change. That's the benefit you get out of that. But if you cannot use a const, then use a let, but don't use a var. That's basically the recommendation as much as you can. Now, having said this, you want to also see if you are able to promote a functional style of code where possible. I'm a big fan of writing code in functional style. What is really amazing is JavaScript has been supporting functional style of programming for so long, almost from the beginning. And a lot of us never used it. Why? Because we were not using JavaScript alone, we were using other languages. And a lot of mainstream languages back then did not support functional style of programming. So now we were programming imperatively one language, so it's natural to program imperatively in another language as well. So we never really experienced it. But it turns out we can write code very nicely if we are able to use this functional style of programming. So for example, I want to total the double of even numbers that are greater than 3 and where the square root is less than 3. Let's think about writing this code. So I'm going to say over here, you have a double of even numbers, so constant numbers is equal to, let's just simply say here are the numbers I want to work with right there, right? So given these numbers, I can say here is a let result is equal to 0, and I want to output the result. So what am I going to do with this one? We could say a for a let, let's actually a constant, a number, of numbers, and you can start with these numbers. Let's just go ahead and say, here's a number I want to bring in. So you have these numbers 1 through 10, right? So bring these numbers, what do you want to do? You can say, let's just take this one here that you want to work with, and let's go ahead and bring that in here. So let's say, oops, let me try this again. So I want to bring this one right here. So I want to say here is total of double of even numbers. So what's the first thing I'm going to do? I'm going to say if number mod 2 is equal to 0 and even numbers, and then number is greater than, right, 3, and you could say math.square root of the number is less than 3. So if all that is true, you can simply say result plus equal to, you could say number times 2, right? So some calculation like that, you can write the code. So it says 36. But the code worked, great, but there's a bit of a cognitive load to understand this code, isn't it? So instead, what if we can write code like this? You can say, here comes the numbers, if you will, and given these numbers, I want to take the given numbers and I want to say dot filter, and given a number, I want to say number mod 2 is equal to 0, and I want to get all the even numbers that are in this particular collection. So we can take this one and you can ask it to provide you those double values. Then you can do a filter. Given a number, what do I want to do? Number, let's say, greater than 3. So then you can say, I want to take that one and do a math.square root and of the number right here, and it's greater than or less than 3, like so, and you can look for that. So that gives you all the numbers that you're interested in. Then you could do, for example, a map, and you can take the number given, and you can say a number times 2, you can double that number. And then once you do, you could probably do a reduce operation, and you could say, I want to take a total, and I want to take a number on my hand, and maybe what I want to do is to say total plus the number, and I want to perform the total of all those values in this particular collection, and you could provide something like that, right? So you can write code like that in a functional style as well. And in that case, your code becomes easy to understand. You are not increasing your cognitive load. You can write nice functional pipeline and so on, and you can start benefiting from the code. So that becomes a nice way to write the code. But having said that, though, don't make the code hard to read. It's a good practice almost always to write code and step back and ask the question, is this easy to read? Is it intuitive? Is it easier to understand? It's a good practice to walk away from the computer, come back after a few minutes and take a look at it and say, is this good? Is it intuitive, right? Don't just write and walk away, but take a look at it again, and helps you to know. So what are some of the things we can do to make this better? So when you have more than one function in the argument list, you probably have seen code like this, right? So if you have seen code like this, you see something like, for example, you see a process function, and then the programmer says a function data curly brace, and then there is the code that goes like this. And then with finishing that, you read that and you're like, and then you are like reading the next one. Then they say function error. Have you ever seen code like this? And then there is more code to it, right? Like that. And then when you are done with that, then they're like with vengeance, function again, and they go on, right? And then it goes on and on and on like that, like so. And when you look at a code like this, right, where you're beginning to read and you don't know where things end and where things start. Ever seen code like this before, right? So how does it feel when you start reading the code like this? Here is something you can do, right? If somebody has written the code like this, find a nice movie, right? Maybe a movie where the villain really wants to get some information from the hero. So what does he do? He takes the hero and puts him on a chair with his hands tied up, right? He's sitting in the chair, and behind him is the bathtub filled with water, right? And what does he do? Are you going to give me the information? He says, no. He says, all right, here we go. And he dunks him in the water and holds him down for a few minutes, right? And then he brings him up. He's like, and he's like, do it again. So just show that clip to the developer. And the developer says, what's this? He says, that's me reading your code, right? That's how it feels, because you're just being dunked into this water and you're like out of breath, and they pull you for a second and then they put you back in, right? That's that code, because this person who wrote the code sends you a clear message. What does this person tell you? I hate you, right? The only time you want to write code like this is when you clearly want to tell everybody in your company, I hate you all, right? There is no humanity. There is no empathy. This is raw vengeance the programmer has written, right? That's how it feels like. But if you ever have to look at this person in the eye, how do you feel, right? And you're thinking, you are the one who wrote that code, didn't you? What did I do? I even took you to lunch last week. Where did that go, right? So there is zero reason to do this. Why? Because this code violates the so-called single level of abstraction principle. also known as the principle called the um, SLAP principle, right? So you have to read the whole thing for you to understand what it's doing. But instead, if you just take, all it takes is this, right? A very small, really a minute small, very small amount of kindness, right? Just a little bit. You are writing the code, and for a minute, this is, have photo of your colleagues next to you, right? Or maybe they're kids, even better, right? If this person is reading the code, they cannot go to their family, right? Because they got to maintain the code you're writing. The empathy kicks in, and you're like, my gosh, I got to be a better person now. So you say a process, and you can now say, handle data. So let's say use data, or handle exception, pass message. You write the code like this, and then you are writing the function use data to do whatever it's doing, and then you have a function called handle exception, which is doing the stuff it is doing, and then you have a function called pass message, and that is doing whatever it's supposed to do. And in this case, what is the benefit of writing the code like this? The beauty is, hey, what are we doing with process? Oh, we are sending it three functions. One uses the data, the next one handles exception, the third one passes a message. I don't need to know how I am using the data right now. I don't need to know how I'm handling the exception. All I want to know is that detail. Well, if I really want to know how the data is used, I can read that other function, but I don't need to look at the other function to handle the data. So you have nice separation of responsibility. Now it is easier to test each of those functions as well. You don't have to worry about the whole function. You just made the code so much easier to understand, so much easier to read, and all it took was just a little bit of discipline, right? And so it's not really taking a lot of effort, but once we make that a habit of writing code like that, guess what's going to happen? Then the code becomes easy to understand, easy to read, and also habits are contagious. When two or three people work together for a while, what do? We kind of do things which are similar, right? So you're writing code in a way, and the other person is writing code in a similar way. If you write better code, most people begin to write better code. You start writing bad code, most people start writing bad code, because we simulate and emulate from each other. So this really promotes. You are doing code reviews, you can call your colleague and say, hey, what do you think of this code? If we rewrite it this way, is it better? And slowly you can promote these good practices. So we talked about a lot of these principles and some of the ways in which we can write better quality code, but that brings us to a few other things we can do. We can do code reviews. Code reviews are a great way to promote better quality code. When you review somebody's code, what happens? The first thing is, if you're writing code, and I'm not saying because we're all malicious or we don't care about what we do, we don't write bad code because we enjoy writing bad code. I mean, do you go home and say, that was a great day, I wrote really crappy code today, what a lovely day, right? No, we don't enjoy writing bad code. I don't think anybody does. We don't realize we are writing bad code. That's the problem oftentimes, because a lot of times your focus is on something else. Oh, how does this logic work? What's that calculation again? How is the tax computed? That's what you're turning in your mind, and you are desperate to get the code written and working. But if nobody ever reads your code, what happens? You write code, and tomorrow you write more code, and that keeps accumulating, and it becomes a pattern and a practice as time goes on. But you write a piece of code, and I realize he is going to review my code tomorrow, and I'm going to pause for a minute and say, let me clean this up a little bit, right? One of the things I always tell is, I tell my wife, we should have people come to our house more often. And one day she said, you keep inviting people all the time. And do you really love such company? I said, no, I want them here not because I love their company. If they are coming, we clean the house, right? When people come over, you're like, oh my gosh, these people are coming, let's clean up the living room at least. This is great. It gives an opportunity for to clean the mess, right? Otherwise, it piles up and you come back to, my gosh, like a tornado went through this room, right? Well, if I know he's going to read my code, I'm going to pause for a minute and say, let me do a little bit of a cleanup right here. Am I giving better variable names? I've written this function in a way. Is it more presentable? Not that he would look at the code and say, my gosh, the best code in the world, but at least he would have less kicking and screaming, and he would give me better feedback to say how to improve it. That's one of the nice things about having code reviews is it gives an opportunity for us to write better quality code because we are like, oh, somebody else is going to look at the code. I better start writing better quality code. That's going to be helping. And when you look at the code review, you can talk about not just where the curly braces must be, but think about, is it a better variable name? Is it a good function name? Is the function at the right level of abstraction? Are there principles being violated? Is the code easier to understand? Is the code easier to maintain? We can improve a lot of these things by doing these kinds of code reviews. Write unit test. If you write unit test, your code is generally better because your unit test help you to think about the consequences of the code you are writing. Is the code really doing what it's supposed to do? Are there edge cases I need to think about that can affect my code? One other reason why unit testing is really important and essential is it is incredibly difficult to unit test poorly written code. If I give you a function which is 7,000 lines long, and if I tell you to write unit test on it, you're going to laugh, right? Because you cannot write a unit test on 7,000 lines of code. And if you do, it is going to send some input and check an output, and everything else is called hope, right? I hope it works, right? And he's like, it works. Well, that's what the users are for, right? If it doesn't work, users are going to tell you, right? Why bother? If they don't tell you, nobody's using it. That's even better. Why write the test on it? Well, the point really is when the code becomes so nasty, we don't really have an ability to test it. So we often, from the, a poorly written code is hard to test. As a corollary, if you're writing test on it, it structures the code very differently. You make it modular and cohesive. That's one of the benefits you're going to get out of it. Excuse me, having said this though, what can you do to really check for a better quality code? There are a couple of things you can do for this. One is, hands down, I would recommend using ESLint. ESLint can be configured for several things. On my system, I tell ESLint to look for double equals versus 3 equals. So if I use a double equals, it'll give me a warning, and I treat this as an error, so my check-in will not even work if I use double equals in my code. You can similarly tell ESLint, make sure that I don't use var in the code. So if you use var anywhere, it'll give you an error. You can tell ESLint, hey, go ahead and make sure where possible I'm using a const. And if I'm using a let where a const could be used, give me an error. So you can start really programming ESLint to give you these kinds of errors. And as a result, if your code has any of those poor qualities, you can proactively start fixing those. That is one of the biggest benefits you're going to get out of using tools like ESLint. So typically what I do is on my CI machine, on my continuous integration server, when a code is pushed, my CI build will wake up, it'll do an npm install, and then it does an npm test and runs all the tests for my system. If any of my tests fail, it fails the build. If my test passes, immediately it runs ESLint. If ESLint is happy, my build passes. If ESLint reports any warnings as errors, my build immediately fails. So as a group, what we do is we say, hey, if ESLint were to fail, we're going to fail the build. We got to modify the code, fix those errors or warnings, and then try committing again. So the steps I follow normally is we do an npm install, we do an npm test, and every step, if there's a failure, fail the build. So npm install, npm test, npm run ESLint. Okay, so all that is great, but in general though, your ESLint doesn't complain, your tests are passing, but you look at a piece of code and you're scratching your head. What's this code doing again? Well, it's not a horrible 7,000 lines of code, but it's got about 3 levels of nesting. It's got if else, if else, if else, and the person who wrote it says, is it really bad, right? It's okay, isn't it? Well, but you're looking at this code and like, gosh, it's going to take me about 5-10 minutes to understand this code. I wish that was really, refactored into methods that are at a certain level of abstraction. So one of the things you can do is you can look for cyclomatic complexity in code. And when you look at cyclomatic complexity in code, if the code is of poor quality, you want to know that it can be improved. And to do this for JavaScript, I use a tool called Plato. And Plato is a tool that will look at cyclomatic complexity and tell you if the code is more complex than you want it to be. And the beauty of a tool like this is when you work collectively as a team, you can tell your team members, hey, let's make sure Plato has a certain value for complexity. If it is poorer than that, let's refactor the code. What I've done in my system is I run Plato as a last step, and Plato produces a report file with that number. Then in my CI build, I open that file and I look at that number. And if the number is lower than a certain number, I literally fail my build. My programmers hate this, right? Because they're like, darn it, my tests are passing, but your Plato is failing. I got to go refactor the code. It's like, yep, that's right. So let's refactor the code and make sure the code is of better quality. So, let's think about this with a little example. So let's say for a minute, let's give it a try here. So I want to go ahead and blow that away. I'm going to say here comes a source directory, and I'm going to do npm init right here. Let's run this. I don't know if I have the connection for the internet or not. Let me just check what this is saying right now. Looks like it's connected. Let's see if that actually works. So npm install, let's say install, let's say a Plato, right? So I want to run a Plato here. So we are installing Plato. While it's doing it, let's talk about it. So I'm going to write code, and I'm going to say maybe one code is better than another code. And I can think a code is better or not. Wouldn't it be nice if we can use a tool to see if the tool agrees? If the tool agrees with me, we'll keep the tool. If it doesn't, we'll change the tool. That's only fair, right? But it kind of gives us a feedback whether it's in the right direction or not, and can be really useful. So let's go over to the package.json file, and what I want to do here is, I'm going to say here is a Plato that I want to run, and what am I going to do for the Plato? I'm going to say run Plato, and do this on recursive source directory, and put that in the report directory. Let's see how this goes. So here is a source, I'll call it verbose.js. As you can imagine, right, the name kind of alludes to verbose. So numbers is equal to, let's go ahead and say list of numbers 1 to 10, and I want to create these numbers I want to work with. So given these numbers, I'm going to say let result is equal to 0, and I want to output the result in the end. So for, let's say, let I equal to 0, I less than numbers.length, and let's say I plus plus, and I'm going to say in this case, if the numbers at location I mod 2 is equal to 0, then I want to say result plus equal to numbers of I times 2. So if I were to take a piece of code like this and try to implement it, the result is a 60. Now the question is this a good quality code or poor quality code? The first good news, it works. The second good news, almost everybody is familiar with this, right? So we look at this code, yeah, we know what it's doing. It's easy to write, not as easy to read. But what's the quality of this code? Is it a good code or bad code? I'm going to say it's not a great code. But what does Plato think? So npm run Plato, let's run Plato and see what Plato is going to tell us in this particular case. So I'm going to go ahead and quickly fix this and see if this helps. -d report, and I'm going to run through this recursively on that. Let's see if that actually helps. So I want to say npm run Plato and run the Plato and see the results. So open report index.html. What does Plato say? It says the code's maintainability is 65%. What do you think? Is 65 out of 100 good number or a bad number? Average. Well, average in universities in the US, that's a F. That's not an average. It's a failing grade, right? So it's pretty bad in that sense. Let's go ahead and try this again. Source verbose functional.js. So I'm going to say source functional.js. Let's move that into source. So I'm going to edit the source functional.js. So what am I going to do in this one? I'm going to say a constant result is equal to, what a relief already, right? So numbers dot, and I say filter, a function number, and what am I saying here? Return number mod 2 is equal to 0, and then I'm going to say dot, let's say dot map. So I'm going to make the font a little smaller so I can actually fit that in, and we can see it a little bit better. So now you can see in this particular case, we brought in the filter function. So map, I say function, given a number again, I say return a number, let's say in this case, let's try it again. So function in this particular case, I say here is a number, and I'm going to say return the number that we want to use right here times 2, so we can double that value, so we can return that like so. Then the last step here I'm going to do is to say reduce, and I write a function which takes a total and a number, and it simply says return the total plus the number like so, and we are returning that particular value. Right? Is that better than the previous one? What do you think? Is that flowing better, easier to understand, right? The code begins to read like the problem statement, right? So I think it's better, but, and it also works again, and it follows the SLAP principle a little bit better, but what do you think is Plato thinking? So if I look at Plato, Plato says, oh, wait, this one was a 65%, right? That's what it says right there, right? 65%. But on the other hand, it says this one is a 93%, right? That's much better, isn't it? So 93% as opposed to 65%, right? So that's much better. So awesome. But then you say, can this be better? Well, I'm going to say, when you look at this code, I'm going to use an arrow.js, and look at the arrow. Well, this is a bit noisy. It's a bit verbose, isn't it? So I go back to the filter function and I say, given a number, what I want to do is to return the number mod 2 equal to 0. And then I want to say in here, given a number again, I want to return a number times 2, like so. And then finally, what I want to do here is, given a total and a number, I want to return a total, plus the number. So when I run the code, the result is still the same. Is it less noisy? Is it less clutter? The answer is yes. I think that's better. What does Plato think? And Plato thinks that's 100%. I'm not a big fan of that number, by the way, because 100 means you rock. No, it doesn't, right? There's still place for improvement. But that's what it thinks is better. But I want to do this a little bit more in here to make it more, readable and maintainable. So I'm going to call this as concise.java, JavaScript. So what does the concise do? The concise says constant is even equal to, given a number, let's say in this case, mod 2 is equal to 0. And then I want to say, here comes a double, and it takes the number and doubles it, as you can see right there in this case. And then finally, I'm going to say, a sum, and that basically says, given me a number 1 and a number 2, I want to return, in this case, a number 1 plus a number 2 in here. So now that we wrote those three functions, guess what I'm going to do? I'm going to say filter is even, and then I'm going to say a map, double, like so, right? So double, and then finally I can say sum, and when I run the code, produce the same result. But what about that code? Is that a lot easier to understand? Very easy to read, right? Because you come in, it tells you what it's doing. Those functions, if they had really useful logic, you can unit test them as well much more easily. I think that is really good. What does Plato think? It should have given me 110%, but it only gave me 100%. Not fair, right? But the point, though, is you can use tools like this to really take a look at how the code can be better as well, and that can be a nice way for us to incrementally improve the code along the way as well, and we can use those kinds of feedback loop. So there are certain principles we often use. We can continue to use those principles for JavaScript as well, like we do in a lot of other languages. Then there are a few things we talked about that are somewhat specific to JavaScript alone. You want to make use of those facilities. Then we talked about how we can write code using lambdas to use a functional style. Then we talked about how when you do pass functions around, don't make it horrible to read. So try not to put a function in an argument list. Instead, write them as a separate function and pass them so the code becomes easy to read, easy to understand. Then we talked about using tools like ESLint to get a feedback on the code and identify some issues with it. Make that an integral part of continuous integration. Every time you run your CI build, you want to be able to get that feedback, the code is of good quality, and you want to fix it. And finally, you can look at cyclomatic complexity, and you can use tools like Plato. And once again, you can use this again in your system to get that feedback as well. So as a result, if your code is more complex than it should be, you can fail your build, and developers can refactor the code and make it better. Hope that was useful. That's all I have. Thank you.